Hello everyone. In this video we're going to do a little bit of review on how to do probabilities when we're doing multiplication with replacement and without replacement, or in other words, independent and dependent multiplication. Okay, so let's look at this first question. So it says, suppose that 58% of people own dogs. If you pick two people at random, what's the probability that they both own a dog? Okay, so this one is going to be an independent example. And the reason is because we are coming from a large population. In contrast to question 4. So let's just look at question 4 really quick. Question 4 is, suppose a jar contains 17 red marbles and 39 blue marbles. If you reach into the jar and pull out two marbles at random at the same time, find the probability that both are red. Okay, that one, in fact, is going to be dependent. And it really all has to do with how big the sample is. Okay, so you can argue that, if in question 3, that if you take one person out of the population, because you selected them, and then you select somebody else, the probability of that next person being selected as owning a dog will actually be a little bit different, because by nature you took one person out of the group. Okay, and that's what happens in question 4 too. Like when we take one marble out, it's going to change our denominator and our numerator as well. It's like it's going to affect our probability calculation. The difference is that we're talking about, like in question 3, we're talking about like an entire country or an entire state. We're talking about, hundreds of thousands or millions of people. Whereas in question 4, we're dealing with a very small number. Now, there's like no fixed point. It's like, where is it big enough or small enough? Typically my rule of thumb is like 100 or something like that. But once you get to these big sample sizes or these big populations, when you remove a single individual from the group, it really doesn't change the probability that much. If you then select another person, like it will, but it might be out to like the 10th decimal place, which in all like practical purposes really doesn't matter. Okay, so let's do this independent one first. So we know that the probability of owning a dog here is equal to 58% or 0.58. And so if we pick two people at random, what's the probability that they both own a dog? Okay, so this is really simple. Probability of dog times probability of dog. And we can just do equals 0.58 times, just click on them again, 0.58. And we get a 33% chance that both people are going to own a dog. Once again, if you pick two people at random, what's the probability that they both own a dog? 0.3364. All right, so that's in an independent example. But in this dependent one, we got to do a little bit more. And we also don't know what the probabilities are. So let's see. What's the probability of a red marble? Okay, so if we grab a red marble, that's pretty easy. We know that it's just going to be we know that there are 17 marbles in the jar, and there are also 39 marbles. So let's first of all figure out, even before we do this, we'll do number red, and we'll do number blue, and then we'll do total. So we know that there are 17 red, 39 blue, and you can sum these up. So just 17 plus 39, and we get 56. Okay, so the probability of just selecting a red marble, just one red marble, is equal to 17 divided by our total. All right, so we got 30% roughly to select a single red marble. Now, if we were to put that red marble back into the bag, shake it up, and then randomly draw a red marble again, then that would be with replacement. And that's totally fine. But this isn't with replacement. It's saying that we're pulling out two marbles at the same time. Now, at the same time, actually, it really doesn't matter. We could pull out one marble and then pull out another one. But it is now going to affect. So now it's like, what's the probability of pulling out a red marble given that we pulled out a red marble? Okay, so if this happens, now we're at kind of a different spot. So if we pull out another marble, now all of a sudden, if we took one out, we are now at 16 reds, 39 blues equals, so you can also do like equals sum if you want to just highlight them together. And now we're at 55. Okay, so now we'll do the probability of red, well, like second pole, is equal to, now I can say equal to 16 divided by 55. All right, we can hit equals, and we're given this 29%. Okay, now in order to get this, what's the probability of this red, given red? It's this guy. This is what it is, that red on the second pole. Given that we just pulled the red, what's the probability of pulling a red? We've got those right there. So now what's the probability? Now we multiply them together. So this red on the first pole multiplied by the probability of red given red. All right, so this is the probability of pulling out two reds without replacement. And we can just say that that is equal to our first red multiplied by the red given a red equals, there is like a 9% chance, right? Or 0.08831. And if we do it in fractional terms, we should get this guy. Let's just double check and make sure that that actually is the right thing. 34 divided by 385. And indeed, we got the right answer. So anyhow, that's how we do these multiple poles, or these kind of multiplication problems, when we are dealing with both an independent situation where one event occurring does not affect the second event, and dependent where one event does affect the second event. Hope that helps you out with your calculations on your individual projects.